Okay, so this is the 2013 free response question number 2 from our BC Calculus exam. So this is something that we actually took a couple weeks ago. So if you'll look at this question, you have this graph up here, and you have two different polar curves. So you have r equals 3, which is this circle, and then 4 minus 2 sine theta, which is this shape here. The curves intersect at pi over 6 and 5 pi over 6. So what you can tell from that immediately is that this point is pi over 6 and this point is 5 pi over 6, the places where they are intersecting. So we have 3 questions here, and we're going to walk you through each one. The first question we have here is A. Let S be the shaded region that is inside the graph of r equals 3 and also inside the graph of r equals 4 minus 2 sine theta. Find the area of S. So as you can see, this is the area that we're dealing with. So before we move on to the math that I've written over there, I want to explain sort of my process here, or how you visualize the area of a shaded region. So the main thing to note here is these intersection points. If you can find those intersection points and they're given to you, then that makes this problem a whole lot easier. Let's just draw these connecting lines to show how we could maybe split up these polar curves and make our jobs a little easier. So the first thing to note here is that r equals 3 is actually just a circle. So this area that's cut off here, because we know that the intersection points, we can figure out that this area is actually just 2/3 of a circle. So pi over 6 plus pi over 6 plus pi, which is this area, is equal to 4 pi over 3, which is the same as 2/3 of 2 pi, because if you remember, 2 pi makes an entire circle. Okay, the other thing to note is that this area up here, it's not affected by the r equals 3. It only matters regarding the polar curve 4 minus 2 sine theta. So really, all you need to do is calculate the area under the graph of 4 minus 2 sine theta from this point to this point, which we're given are pi over 6 and 5 pi over 6. So let's go move on to the math. So the main thing you need to remember before starting for almost any polar problem is that the area of a polar curve is equal to 1/2 times the integral of r squared d theta from whatever your intersection points are. So like I mentioned before, what you want to do first is split your polar curve into 2 different areas. The first is that 2/3 of a circle that I mentioned before. So we know that the area of a circle is pi r squared. So this logical thing to do then is just multiply that by 2/3 and substitute in the r that you have, which is 3. So that leaves you with 2/3 pi 3 squared, which is the same as 6 pi. For this area, you have to use this formula, whereas for this, as you can see, I didn't even need to use this. So that's always a shortcut to look out for. So you're going to want to do 1/2 times the integral from pi over 6 to 5 pi over 6, because those are the intersection points that we were given. And then you want to substitute in your r squared into the r squared d theta. So we know our r is 4 minus 2 sine theta. So if we substitute in 4 minus 2 sine theta squared d theta, plug it into your calculator. Yes, this is a calculator problem, so don't worry. And you'll get something along the lines of 5.859. Add these together, and you'll get 24.709 units squared. And that should be your answer for A. Okay, so now let's move on to B. A particle moves along the polar curve r equals 4 minus 2 sine theta, so that at time t seconds, theta equals t squared. Find the time t in the interval t is between 2 and 1, for which the x-coordinate of the particle's position is -1. So now we can move on to the math over here. we have our equation for r equals 4 minus 2 sine theta, and also what we're given is that theta equals t squared. So because we're trying to solve for a value of x, we need to use the polar equation x equals r cosine theta. So that's one of the things that you have to know about polar. X equals r cosine theta and y equals r sine theta. So right now we're going to be using this equation. So plugging in our r, we can get 4 minus 2 sine theta times cosine theta equals x. Then we're doing some simplification. And then at this point, what you can do is, because we know that theta equals t squared, we can just plug that in for theta. So once we have this equation for x, all we need to do is set that equal to -1. So once you've set it equal to -1, something to remember is when you have an equation that looks as disgusting as this does and as convoluted as it does, what you're going to want to do most of the time is graph the function and solve using second calc 0. So if you take out your graphing calculators and solve this graph this function here, and you solve for the zeros, you'll get that the only time it crosses the x-axis between 2 and 1 is 1.428 seconds. And that's your answer. Okay, so now we're going to move on to part C. For the particle described in part B, find the position vector in terms of t. Find the velocity vector at time t equals 1.5. To start this problem, we're going to want to use the exact same method we used in part B, as in the identity that x equals r cosine theta and y equals r sine theta. So what you're going to want to do is plug in the r that you have, and you'll get 4 sine theta minus 2 sine squared theta for y, and 4 cosine theta minus 2 sine theta cosine theta for x. So a position vector is just a vector with the equation for the x term in the first slot, and then the equation for the y term in the next slot. So all you really have to do is put it in that form. So the vector would be 4 cosine t squared minus 2 sine t squared, and this is substituting in t squared for theta, cosine t squared, comma, 4 sine t squared minus 2 sine squared t squared. So very straightforward. And then this is just a simplification. This will help you. Remember your trig identities. -2 sine of anything, cosine of anything is always equal to negative sine of 2 times anything. Alright, so moving on to the derivative. As you all know, velocity is the derivative of position. So if you take the derivative after having simplified, using, remember your chain rule, your product rule, everything, you're going to end up with something like this, -8t sine t squared minus 4t cosine 2t squared, comma, 8t cosine t squared minus 4t sine 2t squared. I'm not going to go into detail, but it'll take a while and eventually you'll get this. So it's asking us to evaluate at t equals 1.5. So all you're going to do is plug this into your calculator, and you'll get -8.072, comma, -1.673. And then there's this other method, I don't know if you guys have heard of it, it's called n-deriv. And basically, this is all useless. Forget everything I said and use this. If you see a derivative problem, use this, because you don't want to be sitting there on the test doing this like I did. Okay? So
assuming your calculator is allowed.
Yeah, if this is a calculator allowed section. Remember n-deriv. Remember n-deriv. Remember n-deriv.